All right, we need to find the interval of convergence for this power series. We use a ratio test. Okay, so the n plus first term looks like this. The only thing that needs the absolute values is the x. That's the only thing that's at risk of not being positive. Okay, all of that was just the, oops. Okay, this was just the n plus first term. And now the nth term will be what I put next. So rather than divide by the nth term, I'm going to multiply by its reciprocal. So that looks like this. Okay, so now you clean up a little bit. And then we see if we can see what happens when we take a limit. So what do I see here? I see one more copy of a 4 down here. I see one more copy of an absolute value of x up here. And that's really it. So nothing else actually cleans up. So I'm going to write this as absolute value of x divided by 4. And then in the numerator, I have, I still have that n plus 1. And I've got an n squared plus 1. In the denominator, I have that n plus 1 squared plus 1. And then I have another n. All right, and so now we take the limit as n goes to infinity. Now, I like to take anything that doesn't have an n out in front. That's my style. That can be taken out. And so now I'm just left with this expression. And at this point, when you're looking at this limit, if you're coming to this video, you should have enough experience with limits that this should not be a stressful limit for you. Because the numerator, just collect the degree. The numerator is just going to behave like, n cubed. That's its right. That's its degree, and the denominator as well, right? That's going to be n squared plus some stuff times another n. So like, this is that limit, and that's clearly going to 1. Okay, so this limit is equal to 1. So that means we have absolute value of x over 4 times 1, which is this. And what we need by the ratio test is, so we want to know all the values of x that make the ratio test produce a convergent series. So that means that has to happen, times by 4, both sides, and then write it as a double inequality. Okay, and then at this point, remember, you're supposed to check the endpoints because the ratio test doesn't actually tell you what could happen at those endpoints. So let's check the endpoints. So when x equals -4, if you go up, we're just going to put a -4 where there's an x. Okay, so we'll be this series here. N times -4 to the n. I feel like I'm experiencing some lag here, and I don't know why. Okay, all that divided by 4 to the n squared plus 1. Sorry, I forget where this started. It starts at 0. Okay. Okay, now again, this negative 4 to the n divided by 4 to the n, this leaves behind, okay, that leaves behind a negative 1 to the n. This is really slowing down, and I don't know why. Sorry, I'll get through it. Okay, that's a negative 1 to the n. So like if you want to rewrite this series a little cleaner, it would look like this. So negative 1 to the n, and then write it as n over n squared plus 1. So this is an alternating series. So it has like 2 bites at the apple, or 2 attempts to try to converge. It could converge absolutely, so let's check that. If it converge absolutely, you're taking the absolute value of the term, so you're analyzing this. Right? It wouldn't oscillate if you took the absolute value of the terms. Okay, what does that do? That's going to diverge because it's going to behave like a p-series. Okay, I'm just going to say compared to p-series. This is just, compared to this, or it's going to behave like that series there. Okay, so that diverges. So what about conditionally? So conditionally, okay, so conditionally means you just need to determine whether these terms are these positive and decreasing to 0. And they are. Okay, so it does converge conditionally, and so that we're going to count that. So we go put a little or equal to up by the negative 4. All right, and now let's check the other endpoint. Okay, so when x equals 4, it's going to be n times not x to the n, it's going to be 4 to the n. Right, just put a 4 in for that x. Divided by 4 to the n times n squared plus 1. Okay, those cancel. You end up with n over n squared plus 1. Okay, and then that's basically, we already analyzed that, right? That's exactly the same as this series here when we were checking for absolute convergence. That's going to behave like 1 over n, that series. So this diverges. I'm just trying to hang in there with this frozen screen. I don't know what's going on, but that diverges. So 4 didn't work. So this is it. This is your interval of convergence. We included negative 4. We do not include 4.